Huh.
All right, this battery build starts with a donor battery. It used to be a scooter battery, I believe, and just a few teardown pictures because anything you buy is going to be different, but they will be somewhat the same. So just a couple tools there. That's what the battery pack looked like when I first bought it. And then just cut some of the connector wires, pull off that covering. Then we're looking at the battery pack and the BMS. Flip up that BMS, get it off the top, and then cut the nickel strips that hold the BMS on, or pull them off actually with those pliers. And then that's just the underside of that BMS. And then finally pull up all the nickel strips on the top of the battery. Just got to be very careful that you do not touch two nickel strips at the same time. Unscrew the two halves of the cases. There's everything as it comes apart. And then now there's the nickel strips that are left on top of the battery. Okay, I'm going to try to see if I can do some of this tin removal on camera. If you look down here, these batteries have all got the strips removed from them. These this way have not. So I'm going to grab one of these, and then I'm going to do this on camera and see at the same time. Get a screwdriver and I just lift up a small spot to grab a hold of, and then get the pliers, needle nose in there, grab it, and then just roll it. And that comes off really good and clean. Put that in my pile. Other side, get the screwdriver again, bend it up, grab it with the needle nose, and roll it. So that's clean. Then, I don't know if we can see this on the camera, but little nubs it leaves are awful sharp. So I just take this little flat face hammer, pound them just a tiny bit, and it makes them much more smooth, so you get a good contact on the battery case contact. All right, the batteries have all been pulled from their donor setup. They've been cleaned up, and so now it's going through the process of charging and testing the capacity. So this is a capacity tester for batteries. It'll fit the 18650s. It'll work for AA, AAAs. Works for several different kinds of batteries. But they are running in that, and what this device does is it charges the batteries fully, and then it puts a load on them and discharges them. And as it's discharging, it measures the available amp hours. So I'm gonna turn this screen on and then get the camera to focus, but so we can look at battery 1 now. It's down to about 3.47 volts. So it's already run through the charge process. This battery was charged all the way up to 4.2, and then it is being drawn down now. So currently it's pulled 2386-87 milliamp hours out of the battery. Been running for 4 hours, and it just cut off. Put it back on. So that will drain down to 3 volts. and it should end up somewhere around 3100 milliamp hours. So that's battery 1. You can see in the upper corner. Then I'll hit that. Battery 2, so see the voltage is very similar, amp hour is very similar. Drawing that one down. Battery 3, again, voltage is similar, amp hour similar, drawing that down. And battery 4, voltage similar, amp hour similar. So when this is said and done, should they all end up around 3100 milliamp hours or a little over 3000 milliamp hours, that's perfect. From what I'm doing, the batteries are all uniform and they are in good storage shape. Okay, the charging process I just discussed is complete. Let's get it on and get zoomed in. So battery number 1 comes in at 3098 milliamp hours. Awesomeness. 3132 on battery number 2, even better. 3072 on battery number 3. And 3100 even on battery number 4. So that's what I'm looking for, anywhere over 3000 milliamp hours. So perfect for the setup. So now all I got to do is 36 more. So there's 4, got to do 40. So it's a slow process. You can see it took 6 hours on these sets. So slow process, but it is what needs to be done to make sure that the batteries are in good shape. Okay, here's the reason for the rug. So these things don't, I'm in the living room here on the living room rug just so they don't roll around. But now I've organized all these batteries by capacities from lowest on this end to highest on this end. And what my goal is to build 4 separate batteries, because I'm going to have 4 in parallel. The battery is going to be a 4 parallel system. There's going to be 10 batteries in each parallel pack. So my goal is to build those 4 separate parallel packs with as close to the amp hour capacity to each other as possible. Doesn't have to be perfect, but close is better than one having much higher capacity, one having a much lower capacity. So what I'm kind of going to do is I'm going to take one from the low end and one from the high end, and then that's battery 1, and one from the low end and one from the high end, and there's battery 2. One from the low end, one from the high end, there's battery 3. One from the low end, one from the high end, there's battery 4. So there's the beginning of my 4 packs. So I'm going to finish that up and then add up my capacities. We'll be back. Okay, so now here's my 4 batteries. The startings of my 4 battery parallel packs. So these are all be 4.2 volt packs, and they're all going to have somewhere in the neighborhood of 31 amp hours. And then I'll take those 4.2 volt packs and connect those packs in series to get the 16 volts as a battery will eventually be. So now let's add up these capacities and see where we're at. All right, dudes and dudettes, had to move out to the patio. I got some chicken on the Barbie over here for look at my totals, but this came out better than I could have ever imagined. So I've got my 4 different packs, again 4 packs of 10 cells. And this is the milliamp hour totals that I had by separating the way I just did on the other part of the video. So there is only barely 50 milliamp hour difference between these 2 and these 2. I may just leave it like that. That's so little, nothing to worry about. Or I could, find one that's 25 amp hours higher here and swap it with one up there, and then that will make the difference and make them nearly exact. So again, just gonna hope for a better outcome than that. So again, get all these these 4 packs of 10 cells, all coming in at right about 30,750 some milliamp hours, which is 30.7 amp hours. Combine those together, and then take those 4 packs after they're combined and connect them in series to give me my 16 volts. So I will have one 30.7 amp hour battery. And then I've got another set of these 18650 cells that I need to dismantle and put through the capacity checker and all that. And if it comes out as good as this one, I'll have one more 30 amp hour battery. And then I will hook those two in parallel to give me my 60 amp hour battery. So I'll have the equivalent of a Amped Outdoors 60 amp hour battery for next to nothing and a little bit of work. So here we go, on to the next step. Okay, these batteries have sat about 2 weeks since the last video I filmed. I had them charged and capacity tested and all that kind of stuff. Probably wouldn't have had the patience for it, but waiting that long, but I've been out of town. So now, if we voltage test, they are all coming in just under the 4.2 where they were charged at. So again, very little bleed off, very good sign. So again, we are right on track for good batteries, good used batteries. They've all got great capacity. They've all held voltage sitting. So now we are on the way to building finally. Okay, now we finally get to put something together. All right, these little pieces are some 3D printed pieces. They're from a company called Battery Blocks. I guess Sean is the owner, inventor there. Pretty great guy. I've had some discussions with him and traded quite a few emails with him through this building process. But in any event, just a holder, and you can see there is a spot here where we're going to put through a long piece of threaded rod to hold all these together. And then there's a black, obviously, and a red for a positive and negative to help you keep that together. And then in the bottom of these trays, these are magnets. So you set the batteries in there, and they're held in place. So if you look, if I pick this up, there's nothing holding this together but some magnets. So it's pretty solid as is, but we're going to put some through bolts and some of this stuff here in just a bit as we build that. So if you remember in my separation process we just talked about earlier, I had 4 cells. So you can see I've labeled these. There's 1, there's 2, there's 3. And so now I'm going to put together 4, and I kept them labeled because it makes it easier to keep track of where you're at as we start putting these together in series connections. So again, this is the parallel connection. And if you look back here, these there's 3 parallel sets here. We're going to build the 4th one. There's 10 batteries in each parallel set. So as we build a parallel set, we need to keep our positives and negatives all going in the same direction. So these batteries, 18650s, they're all relatively designed the same. There's a few variations and slight variations of styling, but there's a little button on the top where it's positive. You can also verify that with a voltmeter, and then the bottom is flat. So it's a lot like a AA or AAA battery. That little button is the positive. So we want to make sure we set all these batteries into this holder, black part, negative, with the flat piece down. So there we go. So they just pop in, and they, like I said, they hold magnetically in place. So they kind of stay put fairly well when you set them down. So as we set these in place, we're just going to make sure we've got all of our positives and negatives in the same orientation. Positive up, negatives going down into the black portion of this case. One more, one more, one more. All right, so as you do all this, there should never be anything that gets warm. Kind of touch them, feel them as you're putting together. There should be never anything that gets warm, and there should never be anything that sparks. If that happens, you got something going on. You got something mismatched, something misaligned. You got a positive where it should be a negative. Something's not right. You've completed a circuit. So you want to stop, undo, and figure out what you did wrong and keep going. So we've got all these in the base, and then there's our top, there's our magnetic pieces in the top. And so we just set this down on top of that, and now this block is built. And again, as you can see, nothing holding that together, but it is, but those magnets, pretty solid little block there. Again, I'm gonna come in and, this is interesting, my pen just fell apart, but I'm gonna come in and get my marker, and I'm gonna label this one number 4. Again, that's gonna help me keep track of where I'm at as I start series connecting these batteries. And so that is what comes next. So the absolute genius of what we've just done with these connectors from battery blocks is we've built a parallel pack, and we have not used a soldering gun, and we have not used a spot welder, which is normally required for building a battery pack like this. So no special tools required, no special skills required to solder or spot weld all that stuff when you're soldering and spot welding on a live battery. Always makes me nervous. Certainly I've done it before, but that doesn't mean I like it. But man, I like this. I like these battery blocks. No tools, no special skills. Even a dummy like me can do this. Okay, now next we're going to cut some threaded rod that's going to hold those battery blocks together that we just built. So this is a 3-foot piece of 1/4 20. I believe I got it at Lowe's, but Lowe's, Home Depot, any hardware store probably has it. So 1/4 20 fits perfect in those blocks. And we're going to cut this thing to length. Now my battery case I built is 10 inches long. There's a little bit of a reason for that. It fits perfectly in my chines. It could be shorter, but maybe not much, because we need some extra spacing up here for those blocks for some of the connections that we're going to do. We'll talk a little bit about that in another part of the build. But 10 inches on that case just works out about perfect. So this rod, we're going to cut 2 10-inch pieces, and then I'm going to cut 2 7.5-inch pieces. So again, there's a reason for that. We'll look a little bit about that in a different part of the build for how the battery blocks are going to fit into the case. But I've tried to do this build without using any kind of really specialty tools or specialty setups, so anybody could do it. This is a vise that's just sitting on a piece of 1 foot by 1 foot plywood. It's not bolted down to anything. This is my kitchen, outdoor kitchen table. But I actually built this for gun repairs and gun building, so I could do it sitting on in the dining room. I could do it in my home office desk or just anywhere, so I wouldn't have to be out in the heat of my shop. So we're going to use that. I just got a vise. I got some little plastic grips to keep from ruining the threads on that threaded rod. And then just a good old hacksaw. So we're going to cut this threaded rod, again, 2 pieces at 10 inches, 2 pieces at 7.5 inches. When you cut a threaded rod, you need to put a nut on it first. So I'm going to run a nut down to the inside of where we're going to cut. And then that way, when you booger the threads, and you invariably will, as you take the nut off, it'll straighten those threads up. You'll never put a nut on over those boogered threads. So I'll show you that here in just a second. Okay, cut's done. There's my other piece. All right, so see if I can do this on video, but this nut, as you back it off of that cut, it's going to clean up those threads if they're any more boogered. And then if it worked, I can put this thing back on one-handed while looking through a video screen. And voila, I did it. So there's the secret to cutting threaded rod. Now I got another 10-inch piece to cut and two 7.5-inch pieces to cut. All right, all my threaded rods are cut. See them laying over here, we just did. Next, in the kit, in this battery blocks kit, you've got a bunch of plastic bolts and a bunch of plastic nuts. So what I'm going to do is I'm just going to put one bolt and nut into each block just for the time being, just for a little bit extra support, because as we turn and twist these things around, and we're going to add some more bolts and some plates for the series connections and all that, but just this one bolt's just going to kind of help hold things together a little bit as we twist around. So I'll drop that bolt in, comes out the back side, get this plastic nut on it just kind of loose, and then I'm going to do that 4 more times and be back. Okay, as you can see, you got one little bolt in each parallel pack just to kind of help support it. Like I said, it was those magnets did hold it pretty good, but I'm getting ready to connect a bunch of these together, and there'll be some extra weight in there. So if we were connected all these, got all the positives up top, all the negative on the bottom, we'd have one massive 120 amp hour 4-volt battery. That's not going to push a trolling motor very good with 4 volts. So now we need to work on our series connections to get our voltage that we need to run our trolling motor. So I've got these set up 1, 2, 3, 4. Again, just kind of helps organize things, keeps things in order, so when you glance at it, you know where you're at and you know what's going on. So the first thing I'm going to do is I'm going to take number 1 and I'm going to flip it upside down. So got the negative up, got the positive down. Then I'm going to take number 3 and I'm going to flip it. So we got negative up, positive down. So we've got all 4 packs alternating negative, positive, negative, positive. And then I'm going to take on our first negative that's facing up. Again, we have 2 of them facing up. On our N negative, I'm going to write the letter N in black. Again, just for a visual reference, because this side is going to be our negative post of the battery. And then on this number 4 cell over here, just as a visual reference again, I'm going to write a P in red, because this end of the battery is going to be our positive post as we put these things together. Okay, we've got our layout organized. Now I'm going to put these things together so they stay together. So here's, I cut those rods earlier, 10-inch. We're going to put on the bottom. Let's just run this through. You can see, again, these things have a spot at the bottom where this rod's going to run through. So get this rod running through all the way through the bottom of that. I'm going to set it to where the positive end is long. The positive side of the battery, this threaded rod, is long. All right, and then on the bottom on the other side, same thing, 10-inch all the way through. Okay, we stuck something. All right, 10-inch all the way through. And then my 7.5, I'm going to run through up top. So that runs through. You can see it just barely sticks out either side to grab a nut. It's through. Again, just barely sticks out each side to grab a nut. And then I was using those regular 1/4-20 nuts when I was cutting just to clean the threads. But when I put this together, I'm going to use nylon lock nuts. I don't know if you can see that. Hopefully, oh, there you can see a little bit. But a nylon lock nut has that nylon insert, makes it lock like a Loctite does on a thread. You can back it off. It's easy to change. So I won't put these nuts on. I don't think anybody needs to watch that. It's actually kind of a pain as you turn one, trying to tighten on the other end. The first one you put on wants to turn instead. So anyway, it's not that impossible to do, but we're just going to put nuts on these things so we hold this battery pack together in one piece. All right, rods are in, nuts are on. Just a little quickie on what I did to make that happen. Got some vice grips. Put some tape around them to hold this long bolt while I crank that head down, because you don't have a head of a bolt and you turn one nut, the other nut wants to back off. And then on these short ones, I just little tiny piece through with one nut, and then just use some needle nose pliers to hold that, because I don't care if I booger that thread, that'll just become the head of the bolt. If I ever need to take this whole pack apart, I'll just take that nut off, and that one, if it's boogered up, will hold. That might be a good thing. But anyway, that's just the simple way I did it to get those threaded rods bolted in. This is not tight, or it is tight, but there's no torque in it. I don't think there's any reason to have any torque on those threads. It's just snug, that's it. And then the lock nuts will hold it in place. All right, now our battery is physically connected. We need to electrically connect it. So if we put the voltmeter up on the screen a little bit, right now, like I said, we said this is going to be our negative post. This is going to be our positive post. But right now, if we touch our negative and our positive, we got nada, because we got to make those series connections. If we were to flip this over and we were to touch the red and the black from each section, we've got right about 4.2 volts. That's what we charged it to. So 4.2 volts, showing a negative there because I've got the red on the black and the black on the red. But that's the way it should read. So we need to do those series connections. And we are going to do those series connections with, oh gosh, these little things. There's 3 of them, I promise. But somehow, 2 of them just stuck together. Okay, with these 3 things. Are going to make our series connections, and we're going to bolt them across there. But again, we look at this. We decided this is going to be our negative post. This is going to be our positive post. All right, these 2 battery ends cannot have anything connected to them. So what we want is we want our power to come from here. All right, it can flow down, and then across this positive negative connection. All right, so we're going to have a connector on the bottom of the battery there in a minute. All right, so it's going to come down across, come back through here. It will flow, then we need it to flow across these 2. So we are going to have a connector there. And then, so we back up again, it comes down through here, goes across this, goes up through here, goes across that, goes down through here, and then we need another down here to flow through that. And we're going to bolt those in with our plastic bolts that we used earlier. So let's pull that to the side, and let's start on the first one. Again, we can't have anything up here. This is our post. This is our post. We can't have any of these plates up there. So this plate needs to start on the bottom. So we're going to roll this battery over, and this plate is going to go there. And again, we should see no sparks. We should feel no heat. If you got that going on, something's wrong. But this is, if everything else was done right up until this point, you will not see any sparks or heat. So we're going to push this through. We're going to push this one through, and we're going to push this one through. All right, and we're going to turn this back over, and we're going to get some nuts on these bolts. So put that on. I'm going to have to hold the back side. So nut on, and we're just going to do a little finger tight right now. All right, so nut on. All right. So let's look again. We've got negative post. Power can come down through here. It can go across here. All right, now we need it to go back up. It's going to go back up, and then we need it to cross again. So I'm going to leave these two nuts loose that were on the other end of these for right now. But what I also like to do are little checks. So we've got, again, we had no sparks. We have no heat buildup. And now I want to check this post. And so we've got, or check this connection. That's, again, the connection's on the bottom, but across a positive and a negative of this, now we have a mini 8-volt battery, almost 8.4. So 4.2, 4.2, now we have 8.4. So we're good, We've done everything right up until now. So now we're gonna go, again, it comes down, it goes across underneath, it's gonna come up, and then it's gonna cross the top here. So put this one on. No sparks, no heat. All right, so we're good. I'm gonna put this nut on. Kind of finger tight. I'm gonna put this nut on. Kind of finger tight for right now. All right, and then we're gonna go down through there. So now we're trying to build a 4 series battery. Right now we have a 3 series battery built. So we want to double check, and we have no heat, everything's cold. We didn't have any sparks just now when we were doing that. So now this is our negative terminal, but we can't test right, that's another negative. So, but if we were to flip this battery over, if it was a 3 series, our negative would be there and our positive would be here. And you can't see that on the screen. And our positive would be here. Well, we don't have any voltage because I don't have it tightened, I guess. Let's go. Oops. Negative, positive. There we go. So now we've got 12.6, if I can hold it. You can't see that. Let's get that up. Still can't see that. Got glare. All right. One more time. Negative back here, positive up front. Well, let's put our, I don't want to put our nuts on because I need one more connection. It's not making contact over there because we don't have any nuts on it. There we go. Whoops, there we go. So about 12.6. So again, 3 times 4.2, we've got 12.6 once we make the connection. So we are good to go so far. Nothing's sparked. Nothing's gotten hot. So we've got negative. The juice can flow down to here across that bottom plate that we can't see. Up here across this top plate that we can see. It can go down here. So now we need one more plate down here. So we're going to flip this back over. There's our other 2 nuts that we just, or other 2 bolts that we just put through. We didn't put any nuts on. I was having trouble getting the connection with nothing holding it. Now you see why, hopefully. All right, so we're going to put another nut. And get some more nuts out. And we're going to put a nut. And then we're going to run a bolt back through. And a bolt back through. Up. There we goes the camera. All right, so hold these bolts with my fingers on the bottom. One last nut. One last, well, not last, here's a last. So one nut here. Okay, so there's our 4S or 4 series battery. All right, so put a voltmeter back in. Again, we said this is going to be our negative post. We haven't put the post in yet, but this is going to be our negative post. We said this is going to be our positive post, got the P on it. So if I touch, and voila, about 16.8. Like I said, each of these cells are a little discharged after sitting for a while, which is normal. So 4 times 4.2. So there we go, 16.8. That is our 4 series battery. We have electrical liftoff. So now we need to make some connections for our posts, and we need to make some connections to be able to balance charge this thing. So that comes next. All right, next we're going to hook up some balance leads so we can keep our cells balanced and charge them. Now, if you buy a commercial made lithium battery, they're going to have a BMS, a battery management system. So it's a piece of electronics. This is my charger. It's probably, a lot of them are about that size, maybe a little smaller in this type battery. But they are a sensitive piece of electronics that if it gets wet, it's gone. And they're expensive. So you have to have one or the other. Either you have to have a balanced charger or you have to have a BMS. Now, I've flown RC for, I don't know, maybe 15 years, but folks have been doing it for literal decades upon decades with multi-cell batteries using balance leads and balance chargers. So that's what I've chose to do. Now, the reason that the commercial batteries choose to have BMSs is because they're selling to the masses. They're selling to people that are not smarter than their battery. So if you're doing this, you're going to become smarter than your battery. And a balanced charger works a whole lot better in my opinion. A BMS, you cannot tell anything that's going on with the system. With a balanced charger, you can tell everything that's going on in the system. So here's what we're going to do. All right, this is a balance lead. This is actually a balance lead extension. See, it's got two ends on it, and they would plug together if you wanted to, but that's not the purpose. It's to plug another balance lead into this to make an extension to go to the charger. So we're going to cut one end of this off and use this to connect to the battery. They're quite long. This is a foot long. If you buy seems to me every balance lead I can find with only the one end that you need, they're not very long. So this will give us our length, and plus when you buy them by the dozen. They don't cost much of anything. And so I'll have an actual extension to use to connect this charger to the battery when I want to charge it. And we'll look at all that right towards the end of this video, but just to give a little overview of what's going on, what we're doing. BMSs and balance leads connect the same way. We're going to connect one of these leads to each cell, and then a BMS, the end that we plug into the charger, would just be connected to the BMS, which has a lot of the same exact circuitry as this charger, only the charger does the balancing and the charging. So again, I think it's a 2-for-1. I think it's a no-brainer on a kayak. Again, there's no reason to have a BMS on a kayak if you're smarter than the battery. So that's what we're becoming as we build this battery. We're becoming smarter than our batteries. Okay, now our balance lead extension that we have, they have a male end and a female end. We need this male end over here to connect to our charger. So we're going to cut this female end off. Now, this our battery is a 4-cell battery, 1, 2, 3, 4, and we've looked at through all the rest of the video. if you look at this balance lead, there are, it's probably hard to count, but maybe trust me, there's 5 wires on here. There are 4 black and 1 red. Now that is completely antithetical to what I think it should be, but hey, it's the way they come, so it's what we use. But the reason I think this is backwards, it should be 4 red and 1 black, is because we are going to start with the black lead that is furthest from the red, and that lead is going to go to our number 1 negative cell, the cell that we've got. This is upside down on the video on the screen, but our cell where we wrote in on this is going to be our negative terminal. All right, so the first one off this lead is going to go to that negative cell, and then the other 4 in order are going to go to the positive side of each cell. So we have to put, this is our number 1, our negative cell. We have to put the second wire in here is going to go to the positive of the first cell. So this first cell, our negative cell, is going to have a balanced lead here, is going to have a balanced lead here. And then the next one in order, and it's important that they go in order, we're going to put a balanced lead on this red, then we're going to put a balanced lead on this red, and then we're going to put our last balanced lead, which will be the only red wire, on this red. I just got some of these little connectors come in the battery blocks kit, so all we need to do is just cut and strip the wire to put it on there. So what I will also do, I'm gonna leave as much of this length as I can. And if you remember, we have some long extensions on the positive end of this battery. That's to give us some room for wiring and some other things that we need when we're putting them back into one of these cases. So this thing is going to actually end up being on this end of the battery. And so this first cell that's got the balanced lead on both the negative and the positive, those 2 wires I'm going to cut at the very end, so they'll be as long as this whole lead is. And then the next one I'll just cut, a couple inches shorter, and then the next one I'll cut a couple inches shorter, and the last one will be a little shorter. So they'll all end up with this lead being able to position itself at about right here, with generally the same lengths of wire coming off of that. So I don't think I'm going to put every cut on the video, but it's just makes a long video out of an already long video. But again, we're going to cut this very get one with an end cut. We're going to cut our very first one, and then I'm going to strip that back and put one of those terminals on it. So I got this stripper, these tiny little wires. Strip that back. Keep this on the screen. Twist that up so those wires stay together. And then I'm going to get this into, these little things are normally color coded red, blue, and yellow. The red is always the smallest connection, and these are tiny wires. So I'm going to put that into the little red section there, and then this wire in, and then crimp that. Give it a good squeeze. Okay, much like we did with the voltmeter when we were just first connecting these plates, we're going to do a little interim check. So if you look at my lead, I've cut the first wire off. Again, that goes to our first negative post. All right, so that is right here. All right, that's the only one that goes on a negative post. I've cut the second wire, and that goes onto the positive of the first cell. So again, there's one here and one here. That's the only cell that has them on both ends. Then I've cut You can see I've cut this third one a little bit further down, so it kind of lines up with this cell. And we've got a lead connected to that first positive. So right now we have 2 positives connected, 1 negative connected. Now this little device, I call them a cell alarm. I'm not positive that's their actual name. I'll try to put a link in the video to one. It won't be this one because I've had this one probably for 10 or 15 years. I've got a bunch of these things I bought, and I use them again in the RC type batteries, but they're perfect. And we're doing the exact same thing here. So this thing will ride in the battery on the kayak with me. It is a secondary backup to the cell balancing. Call them an alarm. This thing is loud as heck. You know, kind of probably hear it when I connect it up, but this thing will show the voltage of the entire battery plus each individual cell. It'll flash through, but if one of the cells goes out of balance from the others, it'll beep and make it an obnoxious alarm. Or if they all get low, it'll make an obnoxious alarm. So again, it's a nice little safety backup. We're going to have this installed. I'll show you a little bit about how we're going to connect that into our battery housing later in the video. But we can hook this up now. So our system, this little checker is only going to think we have a 2-cell battery because I've only got 2 connected. Again, we're just going to do a little interim check here. All right, this thing can hook up to I don't know, you can count these things anymore, but maybe a 6-cell battery. But so there's a lot of extra pins, but we want to plug this in with the left pin starting into our connector, and some of the pins will hang out and won't be connected at all. And then you go hear that little beep. So it says it's got 2 cells. The whole voltage is 8.3. First cell is 416. Second cell 416. So again, it's going to cycle through and read our cell voltage. It'll keep doing that as long as you leave it plugged in. And that little beep that we heard, it gets louder as we have more cells, but should, oops, so hard to do around the camera. Those beeps, if a cell goes out of balance or the whole battery gets low, this thing will scream louder than you could ever imagine. And again, that's just kind of a safety protection while you're out on the water if you were to start to have an issue with the battery. So we got 2 down, we got 2 to go. Okay, all the balance leads are now connected. So here's my here's the end that I cut off. The first 2, positive and negative on this first cell. Third line goes to the positive on the second cell. Fourth line, this black one, goes to the positive on this third cell. And finally, the red one goes to this positive on this last cell. So everything, all those wires are connected. We're going to tie these up towards the end when we insert into the case. You'll see what we do with that then. But here's all of my everything connected. We'll plug our cell arm in, and we plugged it in backwards. Got to get it from this side. All right, so 4 cells, everything 16.6, and then you see number 1, number 2, number 3, number 4 cell. So that'll keep cycling through, show us our overall voltage, show us our voltage of each individual cell. And again, if one cell goes low, this thing will scream. If the whole battery gets low, this thing will scream. So again, just helps for some secondary monitoring for our battery while we're out on the water. And we're going to also do some other monitoring on this battery, at least I will. It's maybe not all necessary, but I like the 1 is none, 2 is 1 concept. Okay, here's my completed battery. And we'll take a little look at where we're going next. All right, so this is a 4x4 PVC fence post that I just got from Lowe's, and then fence post caps on either end. They're sealed on there, so it makes a incredibly nice battery case, compact, light, waterproof. We need to add our battery connections for our motor. So this is where we're going to plug our motor into. There's a positive and a negative. This is an Anderson connector. I really like these. Look a little bit more about those, put that together. But positive and negative wires go into the battery we've been building. See a little bit more about how we install it on the one that's not built yet. And then this little tower here, this is where that cell alarm hides I was telling you about. And then as you can see, this battery, I had it out on a few miles a trip the other day. Haven't charged it. That's the best thing to do, is leave them in a state of discharge while they're not being used. But so we can see how this thing is working. There's our balance lead. We'll connect another one of those extensions onto that to be able to balance charge it. And then again, this thing can just hide down in this little turret while we're out on the water and be waterproof. So that's where we're going next. Now, I've already cut and drilled this one. Again, not very much exciting to see on a video, but this is a hole saw that's going to be for that cap that we just saw for our balance connector and for our cell alarm. All right, and so I'll show you the piece that goes in there, and then just 2 holes for those gland connectors for our wires to come out. Now, I didn't do this really super scientific, because kind of played with things back and forth and eyeballed things, but when this cap, see this cap covers up part of the end of this fence post. Let's get it back on battery. So that cap covers up part of the end of that fence post when it slides down. So the way I kind of measured this is the edge of this big hole is about a ½ inch away from where this cap rides when it's fully seated. And then these are about a ¼ inch away from where that cap rides. And the hole saw I used for this was about 1 inch and 3/8. So the piece that I'm going to use for that cell alarm protector is this is electrical conduit fittings. This gray PVC. Now the gray is always electrical, the white is always plumbing. Now this particular little piece I couldn't find in any plumbing section. I was just trying to say, I don't guess there's an equivalent to it in plumbing. But these little pieces are made for exactly what we're doing. They're made for an electrical housing to connect either a pipe or a cap to. So this thing goes through the inside. And you can see it's got this lip here that's going to catch. And I'm just going to use some PVC glue and glue that in. And then, of course, this cap just goes on and it becomes what we were just looking at on the finished battery. And then these other pieces, these are 90-degree elbows or glands, wire glands they call them, in a 90-degree fashion. There's a big nut on the bottom. We're going to push this down through, then attach the nut from the back side. It seals to the box. And then these gland connectors are made to where as a wire comes through, and you push the wire through first, and then as you tighten this down, it seals around the end of the wire. So it makes this all waterproof. I'm not sure if it would survive a 10-foot submersion, but it will certainly survive any type of dripping, leaking type of things that go on around a kayak. And it would probably survive some form of submersion, but you never want to purposely try to sink your battery, although it could happen to any of us. So there's what we're doing. So just a couple gland connectors on there. This little turret, I guess I call it, for our cell alarm. So I'll try to put all these little fittings and pieces in the description for the video. All right, here's the PVC glue That's just the 1-part glue. I think I got it from Lowe's again. It's not the 2-part stuff. But just gonna put a little bit on this lip. Oops, I don't want to get it all over the whole thing. But so this lip made a mess, but nobody cares. All right. Goodness, dropped it. All right, push it up through and hold it. This stuff will adhere in a pretty quick few seconds. And I got my scientific tool here, a Crown Royal rock glass. Just poke it under the edge just to kind of hold it up in position, just to be sure. And then I'm going to use my popsicle stick and just kind of dribble into this. Oh, I can't see nothing. Just kind of dribble into this crack a little bit. Not pretty, but I don't care. Just kind of dribble some in, feel that gap. And then it'll never come out. You'll have to cut it off. So we're going to let that dry a bit. All right, the glue's dry. So now to install our 90-degree gland plugs. And they just have a big nut on one end. I'm not sure if you can see that in video, but there's a gasket there. So that's just going to pop into our hole there. And then, let's see, get that on the video. Down inside there, we're just going to put on this big nut. And so think about when you're drilling this hole, that nut's got to fit and still have room against that side wall, and also not be too close to the fitting for our cell alarm. So there we go, that's in. I'll put the other one in, and then it'll be time for some battery terminal wiring. Okay, so our case has got our wire glands on here, got our cap for our cell alarm and balance lead connections. So let's talk a little bit more about why I designed the case the way I designed it. So if we go back to our battery and our balance leads, again, we're going to clean all this wiring up here eventually. But this is going to go into this case. Get these out of the way. All right. So this is our long end of our threaded rod is going to go into here. So as I build, I can't get this whole thing in the screenshot, but as I cut this wire, I'm going to make this wire long enough to where it starts over here. It can go up and then loop back around a little ways to get the plug here. So that gives us a length to insert the battery into the case. This extra length here will give us some room down in the end to for that wire to kind of loop itself over. And then as this goes in to that battery, this little short end is going to be right at that end of the cap. And this longer end, if we can see, there is some space down here. Again, this kind of holds some of our wire. And then if we look down, we're going to get that balance lead to come out through there. You see, you can even see the battery. And then the other reason that I did this length, and I think I'm going to do something different yet, but it is available to do, is that I've got a circuit breaker, and it will fit right there. So you can send that wiring through that circuit breaker and have a built-in circuit breaker to your battery for overload protection. So that will fit. I have that option still, so that the design is set up. And again, the extra space just makes it a little nicer for the wiring and then for the balance lead connections and all those things, even if you don't use that breaker in that position and use it in a different way, which I think I'm going to do in either a later part of this video or maybe in a later video altogether. Okay, now we're going to build the cables that we're going to connect this battery to our motor. So I've cut wire, the red for our positive, I've cut it to 22 inches, so it reaches from the post over here to our gland plug and back out again. And then the negative one I cut to 27 inches, is this 22 plus the 7, that's the width of this battery. Just real quick on this wire is probably way overkill. It's 10 AWG wire, so it's really thick wire. I don't think you need any more than 14 gauge on something like this, but I had it, so I'm using it. And this is silicone jacketed. It's really flexible, and it's also, you see it looks silver instead of copper coming out of there. That's not aluminum, that's tinned copper. So it gives it corrosion protection in a wet environment. So I really like it for anything wire and kayaks. And also, if you're ever going to solder this wire, it wicks up solder like a fat kid that's missed a few meals. But we're not going to solder this particular connection. We just got an eyelet. So I'm going to put eyelets on both of the one end of both of the positive and negative wires to connect to our battery. And then we'll come back with the other end. Okay, now I've crimped the eyelets onto the wire. You can see I've got them both pulled up through the gland connector. They're real short inside now on purpose, just to give me some room to work with out here. I've got them through the gland connector. You have to loosen this piece up to get it to push through. Just don't forget to put it back on. I'm going to leave it loose for right now. And then I've got these wires hanging out this end, and then I'm going to put on the trolling motor end of these wires now. Okay, I think I may have mentioned earlier in the video, I'm putting Anderson connectors on for the trolling motor connection. So this is kind of what one looks like. It's not no wire connected to it when it's connected, but it's got a little sleeve that kind of helps hold them together. Come with the connectors. Anderson connectors, if you're not familiar with them, they have slots to where these things will slide in and clip together. They are genderless, meaning there is no male and female. Any connector will snap into any other connector and make the connection. And then these particular size of Anderson connectors, they can be used for 3 different size wires. This is a 45 amp connector here. It fits this 10 gauge type wire that I'm using. You can get them also in a 30 and a 15 amp connectors, so for smaller wires. So this is not going to be an Anderson connector how-to video, but just a little overview about what I'm doing. And then I got the wire set up for some shrink wrap. There's the little hold together rubber connector that come with it a little piece of extra shrink wrap to hold both wires together, and then just another little bit of shrink to go up next to the connectors once I put those together. So again, if you want to learn more about Anderson connectors, how to connect these things, how to use them, there's a ton of vids on YouTube for that. I will say one thing. Talked to several times in the video about not having specialty tools, but I tell you, if you want to use Anderson connectors, this type crimper is really worth its weight in gold. You can do it with just regular pliers or something else, but if you want to use those connectors, think about that tool, and just Google or search YouTube for how to make the connectors. All right, now down to the final steps. So I got that Anderson connector installed. I got it going, the wire going through the gland plugs. So we come back over here to our battery. I zip tied, so much stuff in here. Okay, I zip tied our balance leads to the edge of the battery in the front here. And so now all we need to do is connect up our positive and negative terminals. So positive terminal, let's see, we can still see, we wrote our P up here earlier. That's our positive terminal. So we're going to push that down, put a nut on the back side of it here in just a minute. And our negative terminal, we can see we still got our N over here. And put a bolt through, push that down through, and I'll put a nut on the back side of that. So we'll turn it up. And we'll put those on. It's tight. All right, and then I'll do the other nut. Then I think I'm going to go through and tighten all these up a bit with a wrench, and then we'll slide it into the case, and this battery will be complete. All right, whoop, there it is. All right, there's the cell checker running. We'll one last connection to these leads, and there we go. We're ready for a test float.
Huh.